Hello, this is a demo on establishing trust for any data between multiple parties using the Cord network as a data trust infrastructure. At first, we will walk through the process flow diagram followed by a live demo using a sample script to depict the flow. At the heart of the process flow diagram is a Cord network acting as a layer of trust between parties making the transaction. In this example, it involves Pulse Energy making peer-to-peer energy transaction with DISCOM using Cord's trust layer. So at first, the Pulse Energy can write or anchor data of any type into Cord.js, which is an open source SDK from Dhiway for the Cord blockchain. An account with sufficient permission is required to write or anchor the data onto the chain. On successful anchor, the chain or the SDK in turn returns a unique identifier for the object which is anchored onto the chain. Preserving this in the source platform and embedding it into the information being shared allows for future verification that the data has not been tampered with. So, Pulse Energy can share the information to DISCOM via verifiable credentials or any other existing flows. It contains the proof identifier along with the information. So the DISCOM in turn can read or look up the Cord.js SDK by passing the identifier of the data which was anchored on the chain previously to verify against the data stored on the chain so that it shows that the data has not been tampered with. It can verify the data which the DISCOM existing has and the data which is present on the chain. So the process flow diagram has two parts to it. The first one we just saw, and it also provides a way to anchor the data and watch on any event which is taking place on the chain. That is the second flow. For example, Pulse Energy updates existing anchored data on the chain, or it can be even created at the first time. It can happen at any level, for example, creation or updation or any state change of a particular data. So whenever the data or is updated or created, Pulse Energy can update it accordingly on the chain. This will automatically broadcast an event. So DISCOM can watch or subscribe to at such particular events which it normally expects by using a watch script on a particular identifier or an event. For example, events here is considered as create, update, or any particular state change. It can also be custom events. So whenever such events take place, DISCOM will automatically be able to know that data has been updated or the state has been changed, say from revoke false to revoke true. So using this state, DISCOM or DISCOM's application can act upon. So we will now see a live demo of these two flows using a sample script and the Cord blockchain. So I will just run a sample script to demonstrate the flow, and we also have a explorer where we can explore the events which is taking place on real time onto the chain. As you can see, we have a set of network membership acquired, which is the permission which I was talking about. You can add someone as a network member, or only then they will be able to make transactions. So we are making few transactions which are DID based, and it can be account based as well. Account, I mean the blockchain account. And simultaneously we can see here the data will be anchored on the chain. At first, before anchoring, there are prerequisite steps which I will skip about, but it's mainly on the type of schema which you want to have, the data structure which you want to have for the particular data, that is called schema. And finally we can anchor the data. Here we are anchoring the data as a VC format. As you can see, there's chain returned a unique identifier for the particular data which got anchored onto the chain. The data here existingly it is of type VC. It can be of any format. Say it can be a string, it can be an object, it can be a binary representation of any data. So it provides flexibility in the type of data getting anchored onto the chain. So it provides a unique identifier. For example, I'm just going to show you, this is the identifier and the data got registered onto the chain. So I'm just going to show you how is the identifier looking inside the chain and what it meant. As you can see, these are the events which took place. We created a few network members and we created a bunch of DIDs for the verifiable credentials, and we finally anchored the data onto the chain as part of the statement. So we have blocks which is getting produced every 3 seconds, and this is a block number where the statement got registered. You can just go in here and see what the data is. As you can see, we submitted a did call having the data which is of schema. This is the schema's ID, and finally you can see the data over here. Yeah, the digest. So you have option of different palettes, so you can customize the palettes how you want to store the data. Here we are not exposing the data as a whole. It's getting hashed and it's getting stored, and it produces a unique identifier. So this produced a unique identifier on the chain. You can query the chain using Explorer itself, or we have the SDK where you can verify the data which you have and the data which is present on the chain, so you can come to know if the data has been tampered or not. I will show you the both ways. The one of the ways here is the using the Explorer itself. You can see the state of the identifier, has it been changed or not. It gives you the data present along with few other metadata, which I'm just going to show you. So it gave us a set of data saying it's anchored, so it shows that statement is present, and we'll just see what is the statement at. Yes, you can see here the digest which has been anchored here, and the data you can hash it and compare if the data matches the same which you have and which originally was anchored and what is currently is. So we can verify it from here, or we have a verification methods for that as well. As you can see, it says a bunch of verification statements here. I'll just show you how the data can be stored. So this is the statement entry. This is how the data got anchored on the chain. The statement entry consists of a bunch of data here again. Main data, the credential hash is going, which we saw the digest. This is the one, the credential hash, which goes as part of the statement entry. So for verification, we can update the data as well, which I was talking about, and you can verify against the properties. Say you put in the data which you have. The element URI is the unique identifier of the particular statement, and then you can put the data which you have, which you want to compare against the chain. You can get back if the verification is successful or not. There are other ways to verify as well. We have a sophisticated and advanced way, such as the API-based verification based on proof. For the VC especially, the VC requires a challenge and a proof, which is cryptographically verified. This is just the data getting verified against the one which is present in the chain. So you can change this. This is how the verification as a basic level is done. And as I said before, you can also revoke the statement, meaning you can say it's no longer active. So whenever you do verify, it says the data verification failed because it is revoked. I can give you an example here. It says the verification failed because the data is revoked. So as I said, you can make multiple, you can restore it back, you can archive it, and multiple, you can also write your custom palettes according to your custom use cases as well. So this is the first part which I wanted to show you. And if you remember in the process flow diagram, we talked about the second part where you can write a script, a simple script, where you subscribe to a particular event or a particular identifier, and whenever that event gets triggered, you can act upon from your application side. So I just have a script here, a sample script, and where you can verify if the whenever the state change happens or a particular data gets triggered. So I'm just going to change this. I'm just connecting to the chain which we have running up, not the local one. So you can just do a watch. You can just run this script, keep it on running, so that whenever that identifier or the event gets changed, this will trigger you that it has changed. Okay, so now we run the script again just to show you how the watch or subscribing of an event here works. So I've subscribed to a palette event statement, and inside statement I've explicitly mentioned that I want to watch only on revoke. So for example, whenever there is a identifier or a state change happens into revoke, this will get triggered. So I will show you simultaneously in the script as well as on the explorer itself. So we are still not in the revoke state, so we are just still creating the chain space, and we can see the list of events which is going on in the explorer. We see the schemas getting created, DIDs getting created, statements getting anchored, updated, and revoked. So we expect that it to be there, and it is there. So here it means that you had watched on particular extrinsic, that is the revoke extrinsic, and you see the data which got revoked. This is the bytes, and this is the account ID which revoked the data. So you can, for example, you can watch on a particular identifier here, or the particular account which is going to make the triggering of your events. This is what we talked about in the process flow diagram. This can be customized according to multiple use cases and for custom use cases as well. Thank you.